Hello, greetings to everyone. Welcome to the 2020 Sustainable Engineering in Industrial Technology Conference. This presentation is on the topic, Study of Partial Shading Effect on Solar PV Model Performance using Infrared Thermography. Introduction. A complete solar photovoltaic system, in which we are calling the PV system, consists of other components depending on the kind of load you are going to meet. So apart from the photovoltaic model, which is the PV model, sometimes known as the solar panel, we also have other components such as the charge controller, the inverter, the batteries, and other auxiliaries, or should we say accessories, like the wire, the fuse, and other protective devices. But in this study, we are focusing on the performance of the module, the solar module, which is the PV. And then specifically, we are studying the effect of shading. Now, shading is one of the factors that affect the performance of PV model. It is naturally expected that when shading increases, the performance of a PV model should decrease. But we also have to know that PV model performance is not solely dependent on one factor, or is not solely dependent on shading, since the solar irradiance can actually also determine how the PV model would perform. Also, the pattern of shading, the type of shading, because shading can actually be partial or it can be complete shading. So the type of shading can also determine the performance, and then we can use this to find the reliability or the long-term performance of this. There are a number of researches done in the area of shading on PV model or PV cells. Dollara et al. Studied on shading of half, that's just 50% of a single cell of a module, and then they realized that when the single cell was shaded, the module output reduced by 30%. So this shows that shading has actually a great effect on the output of a solar module. And this, for any professional or anybody who wants to use solar, must be aware of shading. Anything that will cause shading must be avoided. Pawan and Koresia, also in their study, they try to look at the shading effect based on the connection of the cells. So we have cells that are connected in series and cells connected in parallel. So from their research, they realized that after shading, cells that were connected in series had a given output, power output of about 78.29, while those that were connected in parallel had a power output about 78.10%. After the shading, they observed that the power output for a 1 cell, 2 cell, 4 cell, and 9 cell, that's the cells that were shaded, reduced by 45.29, that's for 1 cell. When you shade 2 cells, reduced by 76.39. When 4 cells were shaded, reduced by 77.96%. So looking at this, you see that just the effect of shading just a single cell is almost reducing half of the power output of the whole PV model, 45.29. And then the 9 cell shaded in series connection, then when it comes to parallel connection, we have, when one cell was shaded, we have 40.97. Two cells, we had 43.1%. So actually, looking at this, we can see that the effect of shading actually affects cells that are connected in series more than cells connected in parallel. Other literature found out in their experiment that there was a drastic drop. This is by Sitanaran et al. Then they advise that non-uniform shading should be avoided by all means. So, like we said in the introduction, there are different types of shading. There is uniform shading that can happen when maybe there is a cloudy sky. The whole PV model can be shaded by uniformly. We also have a clear sky where maybe there is a 3-branch that is just shading a part of the panel, or there are things that are shading in a non-uniform order. Bolani and Zhang reported that for objective shading with low irradiance caused by heavy cloudy days, for instance, a PV array may still generate high voltage, even though current may be extremely low. This is observed in most PVs. You know, most PVs have a rated output voltage, whether there is enough light irradiation or not. So when the radiation is not too much, you are likely going to still see at least your voltage, your output voltage. If it's 12 volts panel, you can see your 12 volts. If it's 14, you can see it, but with very less or no current, because there is no radiation falling to produce current. Meanwhile, we know current is a movement of electrons. So if the electrons are not moving, materials and method. There are various materials used by here. We had a 40 watt monocrystalline PV. Then we also had a 40 watt polycrystalline PV model. We have shading sheets. These shading sheets are actually complete shading sheet, opaque. They don't allow light to pass through them. We have the solarimeter for measuring the solar irradiance. We have the digital anemometer to measure wind speed across around the area. We have the IR imager, which was used for capturing the thermograph or the infrared thermal images. We also have the digital multimeter that were used to measure the output current and output voltage of the PV models, and the shading or without shading. We also have an adjustable mount, which is made out of metal. So this adjustable mount helps us to lift the PV model off the ground and then project it to a height where we are sure there is no shading, not even from human being or trees or anything. The investigation was carried out within the premises of University of Nigeria in Nsukka, and within the time frame of October to December 2018. Our condition here, around that time, there is no rainfall, so it's easy to get a lot of solar radiation within that. Like I said in the previous slide, this is the experimental unit on the left hand side, as you can see here. And this experimental unit, we have the PV model, 2 different PV model. So this is where they are fixed. This bar here is adjustable, so you can adjust it to a particular inclination based on the time of the year, and then we can, and the latitude of the location. We can also do our shading and then take the thermal images from beneath. We will see this in the result. Now the shading patterns that were used, if you look at the first one here, is a horizontal shading pattern, which we shaded 20% of the whole surface area of the PV model, 40%, 60%, 80%. We also have the vertical shading pattern in B, where you can shade 20%, 40%, 60%, 80%. But as we have here, we also have the diagonal shading in the same manner, and then we have the random shading, shade at different places in no particular. The results. From this result, we can observe in the A, which is shading parallel to the short side, that the monocrystalline under 20% shading, as we can see here, actually have the higher reduction in power output of about 87 to 90%, whilst the polycrystalline had a lower output. The reduction in power output was lower in the polycrystalline, which was about 80% here. But when we increase the shading, the difference between the monocrystalline and the polycrystalline was not actually very visible. There is just a little difference in reduction in the power output of both cells, from 40% shading to 60 to 80. Then when we go to the shading parallel to the long side, for the 20% shading, the monocrystalline actually had no reduction in power output. 40% shading, it began while the polycrystalline under 20% actually had a very high reduction in power output, which is almost close to 100%. Then when we shaded 40%, the monocrystalline reduction in power output increased to around 15, where the polycrystalline is still so high. So looking at the shading parallel to the long side, the polycrystalline exhibited high reduction in power output throughout the shading, any pattern of shading that was taken. So, and then we can see that it is very significant. The reduction in power outputs became very significant when the total surface area shaded for monocrystalline was from 60% upwards. So in this kind of shading parallel to the long side, we can also conclude, or we can say that the monocrystalline here from this graph is performed better than the polycrystalline. In the next results, we have the diagonal shading. For the diagonal shading, for 20% shaded area of the PV model under investigation, the monocrystalline actually had a higher reduction in power output than the polycrystalline, which is unlike the previous results. And then for 40% diagonal shading, monocrystalline still had almost 100% reduction in power output, and this also had 97% reduction in power output. From above 40%, almost all of them exhibit the same reduction in power output. This is so clear because if you go back to the introduction, you even realize that there were researches that when half of a cell was shaded, there was about 30% reduction. So this is so clear that if you are shading about 40% of the total cell, you can have a reduction close to 100%. Shading by partial obstruction of direct radiation, monocrystalline had a higher reduction in power output at 20%, while the polycrystalline had a lower reduction of about 30%. of power output reduction. From 40%, like in the previous case, they all had very high reduction in power output, but with the polycrystalline always at the lower end, while the monocrystalline panel is at the higher end. Sorry, we have the hotspots created in the middle, and we also have other hotspots. You can see this area is what we have here, and we have hotspots created here in the middle, and then the other one, the hotspot is not really as pronounced as the one we have in the shaded portion. The thermal images were still taken for the polycrystalline models. So which you can see here, the polycrystalline exhibited a little different thermal images compared with the previous one. So we have the shaded portion at the center, and the hotspot was generated right on top of the shaded portion. So we can say that the shading actually has something to do with hotspot generation. The other part, which is the other model, also had hotspots, but you can see the hotspots were not generated around the same point. We also had a random shading where the hotspots we do not really know the pattern of the shading, but from the observing the infrared image, we can see that the hotspot was generated somewhere around this area. The result of this experiment shows that the efficiency of any PV model is dependent on the type of shading. That means if we are going to use shading to judge the efficiency or how the output of the model, it will depend on the type of shading. It also implies that the amount of shading, as the amount of shading increases, there is also decrease in power output. It was also observed that the polycrystalline model experienced more losses due to partial shading than the monocrystalline model. The PV models experience more losses when the objects are directly placed on them than when the objects were at a distance. That's the opaque and the partial shading that we talked about. The ambient temperature had actually no effect on performance of the PV systems in this study that we just looked at. Then the models with different random and non-uniform shading are more susceptible to hotspots. So when we did the random shading in the last slide, you look at the infrared thermal images, you see there are random hotspots generated on the surface. The study confirms that the finding of bEmmanuel, which was in the literature review, that low irradiance of a PV array will generate a high potential difference, which is the voltage, even though the current will be extreme. In our recommendation, considering the emergence of new solar technologies so as to improve its efficiency while being commercially viable and accessible, we recommend that this study should be under the real outdoor conditions, should be carried out on perovskite solar cells. These are other technological advancement in solar technology, solar cells technology. Results of the outcome of the findings should be compared to those in the silicon crystalline models, so that we can determine which technology performs better, when it comes to which one performs better in the face of shading. Homeowners are also advised to put into consideration cloud and climatic conditions of the allocation when they are selecting the particulars they want to use. These are our references. Thank you and stay safe.